everyone, here we are going to start with exercise 12a of the chapter midpoints and its converse. Now let's start with question number 1. Now here in question number 1 we have been given with the triangle ABC in which this AC is of 5 centimeter, BC is of 7 centimeter, and we have to find the length of AN and MN. We are also been given that M is a midpoint of AB and MN is parallel to BC. So very first of all, with the help of converse of midpoint theorem, we are going to prove this MN is going to bisect this AC. With the help of that, we'll be able to find this AN, as AN will become the half of AC. So in triangle ABC, we are having M is the midpoint of AB, that is given to us. MN is parallel to BC, again given to us. So by converse of midpoint theorem, we get MN bisects AC. That is AN equals to half of AC. Now we know the value of AC as 5. So this will be equals to 1 upon 2 into 5. That is 2.5 centimeter as answer. Now we have to find the value of MN, and that will be proved with the help of the midpoint theorem in the triangle ABC, in which M will be the midpoint of AB and N will be the midpoint of AC. Now in triangle ABC, we are having M and N are the midpoints of the side AB and AC respectively. Therefore, by midpoint theorem, we get Mn equals to half of BC. Now, we know the value of BC, so we can place the value of BC over here, and Mn will be equals to half of 7. That is equals to 3.5 centimeter as answer. Now here in question number 2, we are having a rectangle ABCD, and we have to prove the figure which is obtained by joining the midpoints of each side is a rhombus. So for that, first of all, we are going to prove quadrilateral PQRS as a parallelogram, and after that we'll be proving it as a rhombus. So we made a diagonal AC, and then in triangle ADC, S and R are the midpoints of the side AD and CD. Now in triangle ADC, we have got S and R are the midpoints of the side AD and CD respectively. Therefore, by midpoint theorem, we get SR is parallel to AC and SR is half of AC. So here we have got this side is parallel to this one, as well as this one is half of this side. Now similarly, we can do for the triangle ABC, in which this PQ will become parallel to this one and PQ will become half of AC. So similarly, PQ parallel to AC and PQ equals to half of AC. Let this relation be equation number 1 and this one be equation number 2. So from equation number 1 and 2 we get SR is parallel to PQ and SR is equal to PQ, as SR is parallel to AC and PQ is also parallel to AC. Similarly, SR is equals to half of AC and PQ is also half of AC. Now in quadrilateral PQRS, this PQ and SR are equal and parallel. Therefore, PQSR will be a parallelogram. So as one pair of opposite sides are equal and parallel, therefore PQRS is a parallelogram. Now we know the difference between the parallelogram and a rhombus is that in case of parallelogram, only opposite sides are of equal length. In case of rhombus, all sides are of equal length. If we are able to prove that adjacent sides of parallelogram are equal, then it will be declared as a rhombus. So we'll be proving the triangle RDS congruent to triangle PAS. In triangle RDS and PAS, RD will be equals to PA, as R and P are the midpoints of the opposite sides of rectangle. And here we get RD equals to PA, as R and P are the midpoints of opposite sides of rectangle. Then this DS will be equals to AS, as S is midpoint of AD. Then this angle and this angle, they both are of 90 degree as the vertex angle of rectangle. And here we get angle RDS equals to angle PAS by 90 degree each. Now to prove these two triangles congruent, we have used this side and this angle. So it will be SAS. Therefore triangle RDS is congruent to triangle PAS by SAS. And the side RS will be equals to PS by CPCT. Now as the adjacent sides of a parallelogram are equal, therefore this PQRS is a rhombus. So as adjacent sides of a parallelogram are equal, therefore PQRS is a rhombus, hence proved. Now here in question number 3, we are having a triangle ABC, which is an isosceles triangle in which AB is equals to AC and DEF are the midpoints of the respective sides. Now we have to prove this triangle DEF is also a isosceles triangle. So as we are having a triangle ABC isosceles triangle, here we have been given this AB is equals to AC. Now in triangle ABC, F and E are the midpoints of the AC and BC respectively. So on applying midpoint theorem, we can get EF parallel to AB and EF is also half of it. Now in triangle ABC, we have got E and F are the midpoints of the side BC and AC respectively. So by midpoint theorem, we get EF equals to half of AB. And similarly, we can do for the ED equals to half of AC. And here we got similarly AD equals to half of AC. Now we can put this one as equation number 1, this one as equation number 2, and this one as equation number 3. And from comparing all the three equations, we get EF equals to ED. So from equation number 1, 2 and 3 we get EF equals to ED as EF equals to half of AB and ED equals to half of AC, and this AB and AC both are equal to each other. Now in triangle DEF we have got EF equals to ED. Therefore DEF is an isosceles triangle, hence proved. Now let's see question number 4. Here we are having this figure in which this AB is parallel to CD and this AB is also parallel to PR. Now this P is given as a midpoint of the side AD and we have to prove this PR equals to the half the sum of AB and CD. Now in triangle ADB, P is midpoint of AD and this PQ will be parallel to AB. So by converse of midpoint theorem, we get PQ bisects side BD. So in triangle ADB, P is a midpoint of AD and PQ is parallel to AB. These both are being given to us. So by converse of midpoint theorem, we get PQ bisects BD. That is, Q is midpoint of BD. Now in the same triangle, we can apply midpoint theorem. That is, P is midpoint of AD and Q is midpoint of BD. Now P and Q are the midpoints of the side AD and BD respectively. Therefore, by midpoint theorem, we have got PQ equals to half of AB. Now, as first of all, we have proved this point as a midpoint of this BD and then we have proved this PQ is half of AB. Similarly, we have to do in this triangle also. We have got this one as midpoint. We are first of all going to prove this R as the midpoint of BC and then QR as a half of CD. So similarly, we get RQ is half of CD and here we get RQ equals to half of CD. Now let this one be equation number 1 and this one be equation number 2. And on adding these two equations, we get PQ plus RQ equals to 1 by 2 AB plus 1 by 2 CD. Now PQ plus RQ will become PR and we can take half common from these two and this will become 1 upon 2 AB plus CD. Hence proved. Now here in question number 5, we are having this figure ABCD in which AB is parallel to CD and M and N are the midpoints of the non-parallel side. That is, M is the midpoint of AD and N is the midpoint of BC. Now we have to find the value of Mn if the value of AB and CD has been given in the question. Now first of all, we have to find the relation between this Mn and CD and AB. First of all, we have to do a construction over here and the construction is we'll be joining CM and then extend it to the point P such that PA also lies on the extension of B and A. Now, first of all, we are going to prove these two triangles congruent. Now in triangle CDM and triangle PAM, this DM equals to AM as M is midpoint. Then this angle will be equals to this one as vertically opposite angles. And we can take this angle equals to this one as interior alternate angles. So let this one be angle number 1 and this will be angle number 2. So angle 1 equals to angle 2 by interior alternate angles. Now to prove these two triangles congruent, we have used this angle, this side and then this angle. So it is ASA. After proving these two triangles congruent, we can prove the CM equals to PM by CPCT and also CD equals to PA by CPCT. Now we can apply the midpoint theorem in triangle CPB in which M is the midpoint of CP and N is the midpoint of CB. Therefore in triangle CPB we have M and N are the midpoints of the side CP and CB respectively. Therefore by midpoint theorem we get Mn equals to half of PB. Now in PB we are having PA and AB. So this can be written as 1 upon 2 PA plus AB. Now we are having the value of PA as CD. So we can replace it by this, and this will become 1 upon 2 CD plus AB. Therefore, Mn equals to half of CD plus AB. Now in the first part of this question of 5, we have been given with AB equals to 11 centimeter, CD equals to 8 centimeter, and we have to find the value of Mn. Now using this relation, we can find the value of Mn. So Mn equals to 1 upon 2. In place of CD we will be writing 8, and in place of AB we will be writing 11. So this will be 1 upon 2 into 19, and that will be equals to 9.5 centimeter as answer. And similarly, we can do the rest of the part. Now here in question number 6, we have been given with a quadrilateral ABCD in which the diagonals are perpendicular to each other. Now we have to prove the quadrilateral formed by the joining midpoints of the respective sides is a rectangle. Therefore, first of all, we are going to prove this PQRS as a parallelogram. So in triangle ADC, this S and R are the midpoints of the side AD and CD respectively. So by midpoint theorem, we'll be getting SR is parallel to AC and SR is half of AC. And here we get in triangle ADC, S and R are the midpoints of the side AD and CD respectively. So by midpoint theorem, we have got SR is parallel to AC and SR is equals to half of AC. And similarly, we can prove this PQ is parallel to AC and PQ is half of AC. Now, on getting PQ parallel to AC and PQ half of AC, let this one be the equation number 1 and this one be equation number 2. From equating both of the equation, we get SR is parallel to PQ and SR is equals to PQ, as SR and PQ both are parallel to AC and SR and PQ both are equals to half of AC. Now, in a quadrilateral PQRS, as one pair of opposite sides are equal and parallel, therefore this PQRS will be a parallelogram. And here we get as one pair of opposite sides are equal and parallel, therefore PQRS is a parallelogram. Now to prove a parallelogram as a rectangle, there are two ways to do so. First one is to prove both the diagonals of a parallelogram are equal, or we prove the vertex angle of a parallelogram is 90 degree. So here in this question, we'll be proving the vertex angle of a parallelogram as 90 degree. Now here in this question, it has been given the diagonal is perpendicular to each other. And we have proved this PQ is parallel to AC. So this angle will be equals to this one as corresponding angles. Let this one be X. Therefore angle BXQ equals to angle BOC as 90 degree. So here this is also 90 degree. Now as in triangle ABC we have proved PQ is parallel to AC. Similarly in triangle BCD we can prove RQ is parallel to DB, as R and Q are the midpoints of the side DC and BC respectively. So we get RQ is parallel to DB by midpoint theorem. Now this angle will be equals to this one as interior alternate angles. Let this be named as Y. And here we get angle YQX equals to angle BXQ as 90 degree. So here this is 90 degree and this is also 90 degree. Now this angle is also a vertex angle of this parallelogram. So as we are having the vertex angle of a parallelogram as 90 degree, therefore this parallelogram PQRS is a rectangle. And here we get vertex angle of a parallelogram as 90 degree, therefore PQRS is a hence proved. That's all for this video. Thank you.